Okay, so we did the bits and bytes binary number. We did the we talked about the hertz a little bit. Hertz is what? Actually, it's a hertz is a measurement, right? So actually the measurement of what? Frequency. Okay, so and then we talked about the rate of information, how fast it travels, that sort of thing a little bit. And then we talked about the binary number. Now this process what? Converting to binary number to decimal number. Okay, so make sure you know the rules. I showed you last time. Go back to videos and check if you don't remember the process. So binary number to digital. Alright, so I don't think I have to do it one more time, but now let's look at the next one. Bit. Okay, we did that. Just a combination. We did kilos, like a meg and gig and terabytes, that sort of things. The bytes, I told you that 8-bit is equal to 1 byte, right? Okay, now this is important. So this is decimal to binary number, which you did probably in your middle school days. So before we did the binary to decimal number, right? We did the conversion. Okay, and as I told you that we can represent number by binary number, digital number, even hexadecimal. I told you that hexadecimal number is based on 16. And there's an octal number, and you can be a little bit exotic, make your own number if you want to, like maybe base 7, base 11, base 12. You make up your own if you want to, but ones that use mostly those are binary and decimal and hexadecimal. A little bit maybe octal number too, but those numbers are used most of times. Okay, binary to decimal, we did that. Now this one does what? Decimal to binary. Okay, so you don't have to be a mathematician or math genius. You just have to know the rules, just the process. Of course you can think about it and trying to become a math genius if you want to, but because people have done it already, you just have to know the rules. Okay, what's the rule? You keep dividing by 2. So here's what's the number? Decimal number. Okay, here is a decimal number 13. So I think most of times you did that in your middle school, but I'll do it again for you. So you keep 13 divided by 2, and then you go, okay, how many times can you go? So you go 6, and then you put the remainder. What's a remainder is whatever that remains. So you go, okay, 1. Okay, you keep doing it until you cannot divide anymore. So remainder is 0, 2, 1. This is what? Remainder is 1. Now this one you just have to write it, copy it over to 1. So the answer is 1, 1, 0 1. Okay, 1101. Okay, so that's the process. All right. What? Decimal to binary number. So let's make another problem. So let's say we like to get the hexadecimal number of 130. 130. Okay, now hexadecimal number is base 16. So instead of decimal by 2, we divide by 16. Okay. So how many times can it go? Well, 8 times. It's probably 8 times. 128. So 8 times, right? So I had to do a little bit of work. Oops. Oops, erase that. I'll write it again. 8 times. Okay, so if you go, that's 128. So remainder is what? 2. Now, can you divide by 16 again? No. So we just say 8. Okay, the next one, the hexadecimal number. So as I told you, this one actually, what did I say about F? That was a 15. Now 15, instead of course we went from 15 hexadecimal number, decimal to hexadecimal number. So hexadecimal number to binary number, to binary number, you can do, if we don't know, you can go hex. Now, do you know hex to decimal number? No, you don't. Because I probably didn't show you. Okay, to go to hex to decimal number, F is always 111. Actually, that's a 15. To go to hex to decimal number, you think about this process. Go think about the binary to decimal number. What did we do with the binary to decimal number? We went through it like this. Like for example, 11 to decimal number. Think about the process. We went through, okay, first digit, you go 2 to the 0. And then you put the constant, which is 1, plus the second digit is gonna be 2 to the 1. Okay, you go back to about 3 slides, you will see this process again. So this one is this one, 1 times, important, times. This guy is this guy. So you put all these constants, all this, so you go back to slides, you will see the process, binary to decimal number. Okay, now the hexadecimal to binary number, you go through the same process, except instead of using 2 here, you use 16. Okay, so instead of using 2, this is base 2, that's why you use a 2, you use a 16. Alright, so we're going from hold on a second, binary to hex, no, hexadecimal to binary, decimal number, hexadecimal to decimal number. For example, okay, so what's F and decimal number? So binary number to decimal number went through this process. Hexadecimal number to decimal number, you instead of 2 we use back 6. So let me show you. So this one, you just think about the process. Let me erase myself. Let me disappear for a second. So so this one is what? This one is what? F is what? 15 I said, right? F is 15 times base 16, which is 16 to the 0, plus, okay, now this step, 16 base 16 to 1, okay, times constant, which is F, which is 15. F is always 15 because, as I told you, here the letters. 10 is A, 11 B, 12 C, 13, 14, 15. Okay, so you work out this problem here. Alright, so this one is what? 16 to the 0 is just 1, so 15, right? 15 plus 15 plus little bit crazy number, 16 times 15. Alright, we probably need a calculator to do that. Of course we can do it by hand, but whatever number plus 15. So that's the decimal hexadecimal number to the decimal number. I'm not gonna do it. Okay, so let's look at the process. Okay, now did we do all of them? Okay, so we know we went through the binary to decimal. Now just in your head you should know how to do it. Binary to decimal, okay. Decimal to binary, okay. You to keep on dividing 2. This one you work out those details, okay. And then we go hex, go from decimal to hex. Yes, you keep on divide by the decimal to hex, you keep on divide by the 16. Yes, we did that. Hex to decimal, we did that. We just did that right just now. Okay, what about the hex to binary number? Actually, hex to binary number is probably pretty easy because it's base 16. So you go, okay, well, F is what? F is a 15. So 15 is actually, you know, always 1, 1, 1, 1. You know, of course, if we don't want to go through the process, you know, go through these process, could go a long way. What I mean is this: you first hex to decimal number, hex to decimal number, and then decimal number to binary number if you want to. Okay, instead of going directly here, going directly, you just look up this table, 1, 1, 1, 1. But let's say you didn't know how to do this, then we could go hex to decimal number. Hex to decimal number, F. Now, what did I say about the hex to decimal number? we said, okay, hexadecimal number, we said, in order to go hexadecimal number, we go, okay, you first write it, alright, and then you 16, that's only one digit, so 16 to the 0 power times, okay, to f, which is 15. So 15 times 6 to 0 power, so that would be just 15. Alright, very simple, right? Okay, so, and then once you get the decimal number, we can go binary number, right? So 15, we did that actually, divide by 2, so 7, and that's remainder is 1, divide by 2, that's 3, that's 1, another 1, 2, 1, you just copy over 1, 1, 1, 1, 1. Okay, so you could go this way, but you could actually go directly here. Just look up this table, you know, oh, you go F, okay. Now if you can have something like a 3 as a hexadecimal number, okay, so what you do is A, well, A is 1010 and 3 is 11100. Okay, no problem. So 1010, 3 is what did I say about 3? 1100. Okay, answer. Okay, fairly simple.